Now, let's go back to this form. This is stiffness matrix minus omega squared times the mass matrix. Now, if you look closely, but we have our B's here. We have B, 0.5 B, and 0.1. Now, we have three B's. We have B1, B2, and B3. It means we're going to calculate this matrix, not that vector or matrix, with these three different B's. So first, we're going to calculate the matrix for B1. And the next, we're going to calculate the matrix for the B2 and then for the B3. So this corresponds to the three mode shapes that we are going to calculate later on. Okay, for this first one, for the mode shape 1, we'll have our mode shape 1 coming from our uh, fundamental frequency. We just substitute the value of B1. We'll arrive with this is for our mode shape 1. Now we're going to substitute the B2 to the same equation. We'll have also our mode shape 2. We'll use this matrix to calculate our second mode shape. And for our third mode shape, now we just substitute the value of B3 to, again, the same matrix. We'll have this for our mode shape 3. Now, next is we're going to calculate now the mode shapes. So for our mode shape 1, mode shape 1, since we have already the mode shape 1 in this form, we'll just add the mode shape factor is equal to the null vector. So for the mode shape 1, we have our matrix as, so this is the matrix for the mode shape 1, or for the first mode shape that we have calculated earlier. And then for our mode shape vector, we'll have the mode shape 1 for the first floor, the mode shape 1 for the second floor, and the mode shape 1 for the third floor is equal to the null vector. Now, if you remember, we have a given condition that the topmost floor will have a mode shape equal to 1.0. In this specific problem, the topmost floor is the third floor. Therefore, this one here will be equal to 1.0. Next, now we can start calculating the mode shape per floor, the mode shape 1, or the first mode shape per story or per floor. Now let's start with the least number of unknowns. So we're going to use the third row. We're going to calculate uh, or use this row, the third row, to calculate the mode shape. So how are we going to calculate this? This is just, let's say for the third row, we just multiply that for this one, for the first row of that vector. And then this part here will be multiplied on that part. And then this here will be multiplied on the third row. So that is just equal to 0 times the mode shape 1 for the first floor. Plus we have the negative 5,169.145 times the mode shape 1 for the second floor plus 4,611.539 times the mode shape of the topmost floor, that is equal to 1.0, that is equal to 0. So 0 times P1 or P11 or the mode shape 1 for the first floor, that is equal to 0. We are left with the negative 5,169.145 P12 plus 4,611.539 is equal to 0. Or 5,169.145 P12 is equal to 4,611.539. Now we need to solve P12. So we just divide the whole equation with uh, 5,169.145. Then our mode shape 1 for the second floor is just equal to 0.892. So next is we're going to calculate. We have already the mode shape for the third floor. We have already the mode shape for the second floor. Next is we're going to calculate the mode shape for the first floor. Now we are left with two equations. We can use the first row or the second row. So I advise as much as possible you're going to use the part or the row with the least amount of equation. We need for this one we'll be using the first row because we have a 0 here. The 0 times the other one is just a 0. So the first row, no, we can rewrite that as we have the 5,324.766 times P11, and then we have the minus 4,259.245 is equal to, P12 is equal to 0. We have already our P12, then we will be able to solve the mode shape 1 for the first floor. And then that is equal to 0.714. So you have already our mode shape 1. Next is the mode shape 2. We have we're going to calculate the mode shape 2. Actually, the process is just the same, for similar with the mode shape 1. But instead of this matrix, we'll be using this matrix in calculating the mode shape 2. In the mode shape 2, we'll be able to calculate that the mode shape 2 for the second floor is actually equal to 0.524. And then the mode shape 2 for the first floor is equal to negative 0.658. And then for our mode shape 3, for P2, the mode shape 3 for the second floor is equal to negative 0.694. And then the mode shape 3 for the first floor is equal to 0.103. Since we already have our mode shapes per floor, the three mode shapes per floor, now we can start sketching them. So let me rewrite that just one again. We have our mode shape 1. And then here, let's say we have our mode shape 2. And then our mode shape 3. Then we have our total mode shape. You remember the topmost floor, the mode shape 1 for the third floor, that is 1.0. The mode shape 1 for the second floor is equal to 0.892. And then the mode shape 1 for the first floor is equal to 0.714. And for the mode shape 2, same concept. The mode shape that of the topmost floor is still at 1.0 because this is given in the problem, and should be attentive with this one because other problem may give us the 1.0 at the second floor or probably on the first floor. The mode shape 2 of the second floor is equal to 0.524, and then the mode shape 2, the second mode shape of the first floor is equal to negative 0.658. And then for mode shape 3, topmost floor is still at 1.0 for the topmost floor. The mode shape 3 of the second floor is equal to negative 0.694. And finally, the mode shape 3 or the third mode shape of the first floor is equal to 0.103. We're going to draw the lump mass model of the system. That is a three-story. So this is the lump mass model of the three-story building. And then let's start sketching. The topmost floor is 1.0 positive. It means that if we let positive is to the right, then this is our 1.0. Now for the mode shape 1, the second floor is 0.892. So that must be around here, 0.892. And then for the first floor, we have 0.714. So that is still quite close at the 0.892. So or the mode shape is actually unitless. That is 0.892. And then we have the 0.71. Now we just connect the elastic curve or the clear columns. And then, so this is the mode shape 1. The mode shape 2, so for the second floor, we have 0.524. So that is around this part. And then the mode shape 2 for the first floor should be on the left. That is negative uh, 0.658. This is 0.524. And then this is negative 0.658. Now we just connect them, the columns. So this is the second mode shape of the three-story building. And finally, our mode shape 3, we have the second floor as negative 0.694. And for the first floor, we have 0.10. Just disconnect them. Okay. This is the mode shape 1. Then we have our mode shape 2 and the mode shape 3. So if you notice, the fundamental frequency shows us that the lowest natural frequency uh, among the three will actually give us the mode shape or deformation or deflection of the structure to be on the same direction. So tandaan sila, all of them are on the right side. And for our mode shape 2, the first floor is the shape is on the left, and then the second and the third floor is on the right. And then on the mode shape 3, the second floor has a mode shape on the left. Now, we're going to calculate the total mode shape. You just get the average of this one. And then that will be your total mode shape. So the total mode shape for the topmost floor, so that is 1 plus 1 plus 1, that is plus 1, and then we have 3, and then get the average divided by 3, that is still at 1.0. For the second floor, that if you get the average, the sum, and then the average of that one, you'll have 0.241. And then for the first floor, the average is 0.052. So again, let me construct again the lump mass model of the structure. So again, on the topmost floor, we have 1. On the second floor, we have 0.241. So that must be around here. And then the mode shape of the first floor is quite close to its initial or starting. So this is the total mode shape of the building. This is the 1.0. and then this is the 0.241, and then we have the 0.05. Sum up, let's just remember those stuff. First is get the stiffness matrix and the mass matrix. Afterwards, you get there, this one. The stiffness matrix minus omega squared times the mass matrix. And then you calculate the unknowns by getting the determinant of the matrix. And then finally, we're going back to this equation, but with the addition of our Mochi factor. And then afterwards, by the addition of the Mochi factor, you can calculate the mode shapes, and then you can now sketch the mode shape. Okay, so that would be all. If you have any question, you can just send me a personal message. And yes, just remember this test, and then everything will be fine.